Now we are having our second unit where we are having the first the heuristic search. Again, in heuristic search we are having the best first search. Okay, difference is here bread first in first unit. The best first, then hill climbing algorithm is there, then beam search is there, then taboo search is there. Then we are having the randomized search, that is a simulated annealing genetic algorithms and colony optimization. So in the second unit we are having total six what you can say specific algorithms and two generic algorithms. So first generic algorithm is heuristic search and then second is the randomized search, and in that we are having the number of algorithms to study, out of which we are only considering four algorithms in heuristic and four algorithms in randomized. So we'll try to finish this in a 6 hours, and if required, we can add more hours to this. So let's start with what is this heuristic search. Okay, so just thing. Again, I'm not using any PPT or say presentation slides here. Instead, we'll go with our regular say definition or defining the things, and I think that you will get this more easily than just going through the PowerPoint, or you can say just going through the LaTex presentation. In software engineering, we are using the presentation because software engineering is quite theoretical when it comes to its massive philosophical things. But AI is a philosophical but more practical, and so just giving the information of AI through the things like in a presentation might kill its essence. So we are going to see the heuristic search. Okay. Please check for the spelling. I think H-E, have made some mistake. Heuristic. Heuristic. I always get confused with the spelling of this at least. Thing. So here we are having this heuristic search algorithm. So what is heuristic search? Okay. So what we can say, it is heuristic search. What is? It is a generic definition that I am telling you. A process to solve non-polynomial non-polynomial problems, okay, in polynomial time using some, okay, what you can say, using some guesswork. Now, what is this something? So heuristic search is what? It's a process to solve non-polynomial problems in polynomial time using some guesswork or experience. Because we are talking about artificial intelligence, that's why. And again, this is not the book definition, this is a generic definition which actually gives you what exactly the heuristic search means. So let's see what exactly this heuristic search can be, or what is what you can say, some guesswork or experience. Now okay, I just have to make this more complete, this definition. Experience gain in past or by analysis. So now this is something that is you are having using some guesswork which is gain in past or by analysis. So now this definition is more complete than the first one. So consider this, that you are having total 12 months. Okay, I'm just going to write this 12 month here. So first month is January, then you are having February, then you are having March, yeah, then you are having April, then you are having May, list goes on. Okay, now you are in November and now you are in December. So now if I ask you what are the months for summer, what will be your answer? Anybody? What are the months of summer?
Sir, March to July.
Okay, so you are saying March to July. Some these. And what is the basis you are saying this is these are the months for summer?
Sir, it has been a recurring thing.
Okay, now it's not, it has been occurring recurrently, but in past you actually experienced the summer season from March to July. Okay, your forefathers also what can I say, summarize that the summer season they experienced the summer in this. So what we say that is experience gain in past. For example, if I ask you what is the month for rainy season, starting month for the rainy season, almost everyone will answer without giving a second thought, June. Yes, yeah,
Yes, sir.
yes. But what,
Yes, sir.
but what happened? Not every June is the month for rain. Okay, so maybe last year in June you got a heavy rain, but maybe in this you won't have any rain at all, and you will get rain in July itself. Okay, instead of getting June. Sometimes what happens, even the June, July, and August, all these three go dry, and you start getting rain in September. Okay. Sometimes what happens, rain starts mid May itself. So when we go on averaging, what we found that the guesswork, that is, say suppose for last 100 years, if you take the history of last 100 years, if in that 100 years, say for 87 years, for 87 times out of 100 times, if the rain occurred in a June month, what we will think that rainy season's first month is a June, like that. Yes. So when we say winter, we know that is we starts with November, December, January, and February is the last month. But sometimes winter may happen before November also. For example, right now we got the heavy rain. So instead of getting the October heat, we may get the October cold. It's possible? Yeah. Yes.
Yes, sir.
So it is possible. So simple thing is that when we say heuristical thing, that is something which is either based on our analysis guess, means we try to average and we try to find out this something solution, or it's just the past knowledge. So many times the heuristic will give you the solution. Heuristic will give you the solution, but this solution may not be the optimal solution. Just like the solution that we gave uh, uh, okay, just like the solution that we got or get in some things, like say suppose breadth first search, depth first search, like these algorithms. Okay, because those algorithms, breadth first, depth first, they work on a polynomial time. Polynomial time means within a finite time you can solve that particular problem. For example, let's say suppose if I ask you to what can I say, count the number of stars in a space, how much time it will take to give the exact number? Any one of you? हेलो, मैंने अगर आपको आसमान के तारे गिनने के लिए बोल दिया, सारे के सारे गिन लो, और वो जो तारे गिने हुए हैं, that you have to give in detail, that is these many stars are there. So कितना वक्त लगेगा?
Sir, infinite time.
Yes, obviously infinite time means it is something which is beyond human life, what we consider. Okay, so when we say non-polynomial, that means the time required to solve this particular solution, say problem, is very very high, or it may require generations to solve that problem, and sometimes even after the generations you may not get the proper solution. Okay, you may not get the proper solution. Forget about the stars because it's quite a what you can say different example. Let's now go to the go down, any go down. The go down make we actually stores in a go down different type of grain. Now if I want to check the quality of grain stored in a go down, okay, and quality of all grain, so how we do that? So if say suppose this is the volume of grain in the go down. Okay. Now consider this as a say metric ton, in a few lakh metric ton. Okay. How you are going to check the quality of that grain? How much time it will require if you go for all the grain?
Sorry, a few months.
Few months, few years, many times. It is quite a difficult task. क्योंकि अगर हम few months बोलते हैं तो तब तक आपको grain को you can't can say use that grain. And if you go on checking that quality, if the time is more, grade may get what you can say decay in the process. So instead of doing that, what we do the stratification. Okay, so stratification means, okay, we are having this lump sum of the grain, so we are actually making some what you can say part of it. Okay, so we made these parts, yeah, and from every part of this go down, we pick a handful of grain, okay, as a sample. Handful of grain as a sample. So these are the handful grain samples are picked from every part. This may be few kg. Collectively, all these samples may be few kg. Let's say 1 kg. So which is easier to what you can say check for a quality, 1 kg of grain sample or few lakh metric tons of grain sample grain?
1 kg.
1 kg. So what we say that from this 1 kg, we say from the quality of this 1 kg grain, we say whether this whole is correct or not, whether this whole is of quality or not. So what this is? Our guesswork. So this is what our guesswork. मतलब समझो आप बाजार में गए and to a grocery shop, you go to the grocery shop and you ask the vendor that you want to buy wheat, and then vendor will say, okay, I am having the two three quality wheat here, that is 45 rupees kg, that is 50 rupees kg, that is 60 rupees kg. Okay, and at the corner you are having a cheaper one, that is say 25 rupees kg. So what you do generally, you are not going to check all the wheat, so you just go to that you can say wheat container, and we take only a handful of wheat from that you can say container. थोड़ा सा गेहूं उठाएंगे ना, तो उसको देखेंगे, ओके, whether you are going to buy this or that, and likewise. And what we say from that, okay, this is good, and likewise. So that is what we call as a guesswork. Okay, so this is what we say guesswork, that is comes as a heuristic knowledge. The guesswork here is called as a heuristic knowledge. And how this guesswork is coming? This guesswork is a gain in past, क्योंकि आपने कभी कभी इससे पहले भी गेहूं खरीदे हैं. Okay, इससे पहले भी you bought some wheat, and while buying that wheat you have made that quality check. Yes, you made that quality check, or either you have observed that someone is checking the quality of grain using this method. So you are simply using this method without caring whether the method is correct or not, whether the method is correct or not. So you got this guesswork gain in past. Okay, और analysis, अब analysis भी हम इसी तरह से करेंगे. So this is what we call as a heuristic search. This is what we call as a heuristic knowledge. And all the heuristic search algorithms gives you the approximate solution. So you are getting this. Hello?
Yes, sir.
Yeah. So if you are simply actually trying to solve the problem which is otherwise quite unsolvable or very difficult to solve. Okay, that is within a finite time, and that is what we call as a heuristic search. For example, let's just suppose mm, I'm now giving one example which may be quite related with our everyday life, quite related, what we call as a heuristic search. We consider certain type of things in a person which actually shows certain type of qualities, and we go on doing that. Okay, so what will happen if you go on doing that? मतलब आपको पता है if the person is having a broad shoulder must have to be a bodybuilder. If a person is having a thin what you can say physique, must be either a genetic problem. Okay, that is what you can say, because his genetic is like that, or it must be the person is not having a good eating habits and he is malnutrition. Okay, so what this we are actually considering or doing, मतलब for example, if some person is looking at something, we consider that person is either observing or obsessed with that particular thing, and all these are our guessworks. All these are our guessworks, and we actually try to adapt this guesswork when we go on doing certain type of characters, when we are doing what we say acting and likewise. So that is again the type of heuristic search, or that is what we call as a mimicking, that is an artificial intelligence. So heuristic search won't guarantee you the absolute solution. Heuristic search won't guarantee you many times even the correct solution. The only thing is that heuristic search guarantee you a solution to a problem which is otherwise unsolvable, which is otherwise unsolvable. Take an example, I'm just giving you a simple thing of the heuristic search. Let's say you are on your motorbike. Okay. So here you are on your motorbike, and your motorbike started. You started your motorbike, and you are here at this position, and your motorbike is going in this direction. In this direction, suddenly you got trifurcation. Instead of bifurcation, consider you got a trifurcation. Now you got this trifurcation. Here you are having a stone. Here you are having a stone, and here also you are having a stone. Okay, and it's saying your destination from this 10 kilometer. Your destination from this stone is 10 kilometer. Here it's saying your destination is 9 kilometer, and this is saying your destination 12 kilometer. Your destination 12 kilometer. Now you are using the heuristic search. You are using the heuristic search. Your past experience is that 9 kilometer is lesser than 10 kilometer and 12 kilometer. Is it correct or not? 9 is less than 10 and 12?
Yes, sir, it's
Yes.
correct.
Why we know this? From our past experience. Okay. अभी समझो. Now this is 10 kilometer road is like this. Quality of the road. 10 kilometer road. Okay. 12 kilometer road is like this. Quality of the road. And this is your 9 kilometer road. So now just tell me which will take more time.
9 kilometer.
9 kilometer. Yeah, but based on your past experience, based on your past experience, if you are using the heuristic search, you will use the heuristic knowledge, and you will consider that last time when you go by the 9 kilometer road, okay, in some other places, in some other direction, you reach earlier. So without thinking about what will be the road quality ahead, what is the road quality ahead, what you will do, using heuristic search you will choose this 9 kilometer road, and you may end up in a bad road. So heuristic knowledge or heuristic search not always give you the better solution. Okay, it guarantees you the solution, but not always give you the better solution. So many times the heuristic search is something like you can say it is like a greedy search. Okay, that is you try to get what seems to be very good for you right at that instance only, and that again based on your past experience. So whatever analysis you are doing at that time or something is a very shallow. It is not an in-depth analysis of the entire problem, and that's why heuristic search may give you the solution. Okay, sometimes this solution is completely wrong. Okay, but it give you the solution, which is not always the case in other type of search. Okay, because in non-polynomial problems the other type, but if you go with the other type search which are not non-heuristic in nature, you will get the optimal solution, but the time required will be so high to get that particular optimal solution that instead of using that, it is better to use the heuristic search. It is better to use the heuristic search. It is just like that means it is something that you want to be get done, and when quality is not the issue, when quality is not the issue, I think heuristic search is best option. But when quality is the primary focus, instead of using heuristic search, it will be best to go for other non-heuristic search algorithm that we have seen in first unit. Okay, in first unit we have seen this what call as a state space search algorithms. We can go for that if quality is the first, because that gives you the what you can say the complete solution, optimal solution, which is not the case of heuristic search. Another example for the heuristic search I am giving you how this guesswork and these things happens in a computer now. Now let's consider that you are having a puzzle problem. Okay, so here you are having a 8 puzzle problem, what we call. Okay, so in 8 puzzle problem, what we generally have this one, this two, three. So and always search is something that is you are trying to find out some solution. So or what we can say, we can consider that you are having a starting point and you are having the ending or goal point. So let's say this is the start state of your problem, and this is the end state of your problem. Okay, this is the end state of your problem in a 8 puzzle thing. So in 8 puzzle, you generally have one empty space. So I'm just showing this empty space here. Let's say consider this is the empty space, and here you are having the numbers. So I'm saying 1, okay, 2, 3, then you want 4. This is your goal state. 4. Then you want here 5. Then you want here 6. Then you want here 7. Then you want here 8. This is how you want your goal state to be, and the initial state that you have got is 1, 8, okay, 7, 6, 4, 2, 3, and here we are in the 5. So this is your initial state. What you require to do, that is you require to transfer this into this goal state, into this goal state. Now if you know with a state space search, if you use the breadth first or depth first and something, the complete you can say space search, that is if you go on drawing the tree diagram for all these moves, is going around where few billion moves are possible. Okay, it's a something like say around 3 raised to power 20 moves are possible. Okay, so instead of using that, because if you have that many moves and if one move is taking 1 second For 3 raised to power 20, you are actually wasting 3 raised to power 20 seconds. That if you divide by 60, you will get the minutes. That you divide by the 60, you will get the hours. And that if you divide by 24, you get the days, and that if you divide by 365, you will get the number of years, and that may be at least a million year time may require to traverse the entire state space search. This is quite what you can say a vast time required to solve this problem in its entirety. So instead of that, we go with the heuristic search. So what is heuristic search? Heuristic search says what is the difference between start state and a goal state. So it says that is how many things are there. Here you are having one. One is at its time. Okay, so one is not shifted. That means you require not to move one. Okay, 8, 7 is there. 8 is shifted by how many places? 1, 2. Okay, or 1 and 2 places. So you got the 2 moves for this 8. Then for 7 you got the 0 moves. For 7 you got the 0 moves. 4 is shifted by again 2 places. So you for 4 you are having the 2 moves. Okay, then for 6 is shifted by one place and 5 is shifted by one place. So for 6 you are having 1 and for 5 you are having 1. Then you are having for this 2 shifted by one place, so one move is required, and for this 3 you require one move, okay, in the direction. So this is what you get. Our space is here, so we are not considering this. So if you go with this, if you go with this calculation, what is your calculation? 2 plus 2 is 4, and this 2 6 and these 2 8, this 2 8. So if you want to reach to the goal state, if I want to reach to the goal state, I get here two possibilities. This empty space can be go upward, or this empty space can go downward. This empty space can go upward, or this empty space can go downward. So here I will get those spaces. Here I will get those spaces. Let's now consider that this space is moved in this direction. That means 3 is now moved to this, and space is at this direction, and here is in upward direction. So space, empty space is occupying the space of 5, and likewise. So at here also you are trying to calculate the number of moves possible for this displacement. So if this number of moves possible for this displacement are now less than 8, okay, this number of moves are possible in for replacement are less than 8. This is the difference between your G and S. Okay, so when we say G and S, if this is less than 8, you consider that it will, or you guess or you assume that it will lead you to the resultant state, that is your goal state, and you will choose that path. So you may reach or may not reach to the path because you don't know what will be the next move is, okay, and so it may give it will give you the solution, but that solution may not be optimum. You are getting this? Hello?
Yes, sir.
Okay, so we are actually calculating what the numbers. We say the computation required is 8, and the next computation should have to be less than 8 or equal to 8. Okay, इससे अगर ज़्यादा है, say suppose here you are having this computation equal to 8. Okay, and if you are having this computation, if we move this space upward direction, if computation required is 9, the heuristic search will say that choose this path, choose this path. Heuristic search will say choose this path. So whenever it see something which is, now when you choose this path 8, and if say suppose in next iteration you got say here 3 options, because now when space is occupied by these three, space can be moved to its original position, space can go upward or space can go this sense. So you will get these three paths. Now let's consider that at this you require 9, here you require say some 7 computation, and here you require 8 computation. Okay, same computation. So in that case, heuristic search will ask you to go through this 7 without considering what will be the future. Let's say for this 7, all the new combinations are requiring either 8 or 9 computation, either 8 or 9 computation. So what this is a dead end. In that case, you require to backtrack, that is depth first search, and now you will consider from this or this. Again, as per the heuristic search, you will go to the 8, not to 9. Okay, now if at this 9 you get anything larger than this 8, so if you got this 9, okay, you got 9 here and you got 9 here, in that case heuristic search will ask you once again either go back or you can go straight forward to this 9. Okay, less than, but you will go here. Now you already visited these and likewise. So it's not always possible by the heuristic search that you will get the solution which is optimal, but you are still getting some solution, and that again in a polynomial time, and that's why it is heuristic search is used when the problems are unsolvable, generally using straight mathematical logic. So heuristic is something like your fuzzy system. You got this? Hello?
Yes, sir.
Yeah. So another example I just want to clear first what is heuristic. Then only we can go through the different heuristic algorithms so that we can better understand the methods and what you can say concept used there. So I'm just giving you the another example for the heuristic search or heuristic algorithms or heuristic knowledge. So let's say suppose here you are having the tree, and on this tree you are having say 100 birds, but and here you are say here you are having a hunter. Now this hunter used first a bow and arrow, and he killed, let's say, 3 or 5 birds sitting at this, or can say, portion of the tree. What will happen? He will observe that when he shoot arrow to these 3 birds, and by chance he got all 3 birds in a single arrow. Just consider that he got 3 birds in a single arrow. Okay, but arrow made some noise and something. So out of the rest of the birds, let's say a flock of birds of say of 40 or 60 flies away. So he killed 3, 40 flies away, and still you are having 60 birds on the tree. Still you are having the 60 birds on the tree. This is the knowledge that you gain on say Monday. आप मंडे को शिकार करने गए and you got this knowledge कि आप जब बो और एरो लेके जाते हैं you got this tree. Now next day you go to some other tree, okay, which is again having many birds sitting there. Let's consider here you are having 100 birds. You are having 100 birds. Now you once again directed towards these 100 birds, and you are done the same thing. You shoot towards tree. You shoot towards tree. But now this past experience, okay, to get 3 birds in one, you can just shoot, but instead you wasted 3 arrows. Instead you wasted 3 arrows. At the same time, these 3 arrows made some noise, which caused, consider that is 80 birds to fly away. 80 birds to fly away, and 20 birds are in such a position that you can't shoot them. Okay, they are sitting in such position on tree that you can't shoot them. So this past experience which was with you, which you tried to use as it is, next day on a Tuesday, won't work here. Won't work here. This is heuristic knowledge or heuristic search. This is heuristic knowledge or heuristic search. It may or may not work. Always keep this in mind. Means if you are having a robot here instead of say hunter, and if you ask a robot to shoot something, robot will observe everything using its sensors and everything and will do the task, and then it will register that same thing in its memory and consider that if you repeat the thing you are going to get the same result. For example, when we say 1 plus 1, okay, here say whenever we say 1 plus 1 okay, no matter how many times we say 1 plus 1, we always get the answer 2. We always get the answer 2. This is non-heuristic knowledge. 1 plus 1 is always 2 is a non-heuristic knowledge because it always gives you the optimal solution. But if you are having 1 plus some variable x, okay, which actually changes over some time t, x variable which actually changes over some time t, where x is equivalent to 1, and so it must have to give you the solution 2, okay, but this 2 is starred 2. I'm saying this is as a star 2 because it may be 1 plus x at the time t equal to 0, it may give you the 2, and t equal to 1 it may give you the 3, t equal to 4 it may give you the 11, and t equal to something it may give you the 1. So whatever the solution that you are getting a solution. There is no guarantee the solution is correct. There is no guarantee that solution is correct, and sometimes you won't get any solution at all. That is what we call as a heuristic. Getting this? So heuristic
Yes.
is something what we call as a fuzzy logic, or is actually go with the fuzzy. It's not absolute one. So here you have this point, you are having this point, you are having this point. That is not digital in a sense that is you won't say. So when you say heuristic knowledge, we are either working some guesswork, we are actually working on some guesswork, or we are having some experience. And how we are having this? All these are gained in our past. Okay, gain in past accident means by doing certain type of operations or by doing certain type of analysis, means without doing that is simply by observing. मतलब समझो you are at a bank of a river and you find one swimmer, so you find that swimmer is swimming in water very smoothly just by doing certain type of movements, hand and legs movement. So you say, okay, it's okay, we can do that hands and legs movements very easily because those are the only observable movements that you can observe now. That is your analysis. What you not observe that after what you can say giving a very much time to that particular process, that swimmer learn to balance his body in water, and then only those movements of hands and legs are working for him. Okay, so if you go without say protection just by observing some swimmer into the water, okay, हाँ मैंने देख लिया ऐसे हाथ हिलाना है ऐसे पैर हिलाना है and I can swim in the water, what will happen? You will drown in the water instead of what you can say becoming a swimmer, and that is what we call as a heuristic search or heuristic knowledge. So when you are using the heuristic search algorithms for artificial intelligence to help our robot to learn by observation or by registering his past experiences, you must have to make some what you can say room in the robots experiencing or robots artificial intelligence system, such that the heuristic algorithms then must have to be used, and just not to get this knowledge, but say in practical, not always heuristic knowledge fails. Heuristic knowledge in practical always give you the results which are approximately correct. And so when you are say, for example, there are always a pattern with every natural being, and so when a robot observe that natural being and register that natural being do this type of things when such type of things happens, this type of things when such type of things happens, so based on some similarity index, it can give you the finite and near to approximate result, which also called as e approximation and something. So heuristic search and heuristic algorithms, just not search, all type of heuristic algorithms guarantees you only approximate solutions, and it not guarantee you the optimal solution. It even not guarantee you the correct solution. It will guarantee you the solution. This is the one advantage of heuristic search, and heuristic algorithms and heuristic search are used to solve non-polynomial problems, the problems which are not solvable in a finite amount of time. For example, say suppose if you ask me a question, how many hairs are there on your head? I will answer you directly, there are around say 3 lakh. And if you say what is the proof, I will say let's count it. Yeah. So this is heuristic. हम जिसको कॉमन सेंस बोलते हैं ना बहुत बार, okay, you will get something, but that thing may not be the correct one, but it will solve what you can say the situation, at least for that instance of time. Okay, so this is what is the basic what you can say information about only one point here. I am not saying search, and when we say one point, I am only saying heuristic. Okay, we try to understand what is heuristic, and based on that we try to understand what happens if we applied it in a search, and what happens if we applied it in a different type of algorithms. You got this? So I think you all got this. Next lecture,
Yes, sir.
yeah, in next lecture we will go through the algorithm based first search, hill climbing, beam search, and taboo algorithm or taboo search. Then we will see what is randomized search, okay, and how this is randomized search or randomized algorithms are different than heuristic. And then we will go with the simulated annealing, genetic algorithms, and ant colony optimization. Okay, so with this, I am stopping the today's lecture.